Hello everyone. Today I want to show you something about mocking in unit tests. Why it is good to have a mock framework, and why do you actually need one of those. Let me start with the project I will show you and how we will experiment with. You know it from the previous sessions. It's the application where we showed you the REST basics with Spring REST. The configuration is pretty much the same. The only thing I actually introduced are some additional methods in the animal service. As you can see here is something like an add if not existing method, and I removed the repository or the data that was actually in it here. There were just the lists of the animals here. I removed them and I just added a repository here. Dependency is another Spring Bean. This is something like the data layer. I didn't implement the database here, but I just moved the collection of the animals, our data collection, to this class. I added also some of the methods that we actually needed later on in later lessons. We will show you how you could actually connect a database to hold your data. For now, you just see the repository annotation, which is common sense for using when you somehow need a repository, data repository. It's almost the same as using a service class, just another annotation for defining repositories here. So what we actually have additional here, as you saw here, there's no anonymous inner classes here. I just created a cat and a dog class because I don't like anonymous inner classes, so I just created an implementation, two implementations for the animal interface, you know, from before. So this is all quite the same as before. The animal can talk and has a name. So there's nothing actually changed. Okay. So now, as I said at the beginning, I wanted to talk to you or teach you something about mocking. First of all, why do we even need mocking? The idea is that we actually like to test not the whole call stack. For example, if you want to test the getAnimalByName method here, we don't want actually to test the animal repository also. We just want to test the implementation that is inside this class here. So we don't care we don't need to or want to worry about what the getAnimals method of the animal repository actually does. We want just to somehow define what is the return value of this method. So before I show you how it's done with Mockito, a mocking framework, I will show you how you actually have to do or would do it if you don't have a mocking framework. I wrote a test that actually shows you what you have to do if you don't or want to do testing and just want to test the single layer, the single service method, the getAnimalByName method, if you don't use mock frameworks. So what we do here, this is a simple JUnit test class. We have different member variables here, and we have setup method, which is annotated with @before, which actually gets executed before each test method, single test method. And in our before method, we just create two animals, two cats named Max and Mike, and we create this animal service here. The animal service is the service we want to test, and we pass the animal repository, not the original one that actually should be wired by the Spring service. We just want to give our own. It's something like we emulating the behavior of the animal repository here. So we're fixing it. It's like a fixture. So we're saying that the getAnimals method returns always cat Mike and cat Max here, these two. And the removeAnimal method actually returns always true, and the addAnimal method returns always true too. So that's what our stub is. We say we fix all the values here. So what we can do then is we can write based on this assumptions, we can write our tests here. So we first of all maybe we want to test if a non-existing case, so where the animal that we search for, the name that we search for, there's no animal in our repository actually. So we do that, and we pass Mark, and Mark is not in the repository here, which the getAnimals method from the repository might return. So we look back at the animal service. This method here actually returns just the two cats that we set are in here, so cat Mike and cat Max, and they both have not the name Mark. So what we then expect is that the return value, the optional, should be somehow an empty optional, so is present should return false. So we test the other case also, where we ask for an animal which is in the list, namely Mike here. And this is the same thing here, but the difference is that we actually expect the return value to be true, or that the animal actually is found here, or some animal. So this looks pretty okay, right? But the problems that you have when you use these implementation style is that maybe you want something, you have different test cases where you need the methods to behave differently. So you can't actually just create an animal service up front here. Maybe you just have to create for the empty case, where you actually want an empty list of animals for whatever reason, so that the getAnimals method of the repository in the animal service has actually an empty animal list. Therefore you have to change or exchange the animal service. So in order to do that, we could somehow create here the new animal service that we want to test, and add our fixture here as a parameter, as constructor parameter, and call the method afterwards. This would work. You could actually do something else, like add your class members in this class here, for example, where you put in the list of the cats here as class member, and then it would work also. Then you just have to change the list here. But it gets more odd if you, for example, want to throw exceptions, and you have to do more different things, and so that maybe you want to say something like, my method throws an exception sometime, and I want to test this case. When the method of the animal repository, for example, removeAnimal, for some reason throws an exception, I want to test this case. When it throws an exception, that the service method that calls this removeAnimal of the repository actually behaves correctly. This is really hard to achieve when you program this way here. That's why there are frameworks that actually helping you to achieve the same thing in a much more readable style, reusable style, and it's just, I wanted just to show you that you don't even need a framework. You can do that without a framework, but it gets easier if you use a framework. So let's go to the actual use case where we use a framework. Before we can use a framework, we have to actually modify our build Gradle. I did that already. So I added here an dependency for the test compilation only. We don't need it for the compilation because we don't want to ship it afterwards in our production environment. So we just added test compile and added the newest Mockito core dependency here. That's pretty much it. Afterwards you have to refresh the project and then you can start writing Mockito tests. I already wrote a Mockito test, so I just show you the same test that we wrote for the animal service without Mockito. I want to show you with using Mockito framework. So let's have a look at it. What actually changes is we could choose, or we have to define a Mockito or a JUnit runner here that we do with a run with method. We could skip that, but if we do that, we have to define this add before method that is commented out here. So we have to pick one of those in order to that these annotation work properly. So these annotations here, as you see, Mockito works with annotations also like other frameworks do. You can say something like this one here is a mock object. And with this method here, you can say these annotated member has a constructor, and a constructor try to insert all the mocks that you can find. So something like dependency injections for mocks. So this one here actually does some magic and calls the new, we could write it out, for example, if you, maybe it's not clear enough, you can say new, this is quite the same as saying new animal service from animal repository. Somehow, this is what inject mocks does. You don't have to do anything, you don't have to pass the parameters, it just does the stuff for you. So that's for just the setup part here. But maybe there we talk later. So just that you know that these annotations are relevant and needed, because otherwise we are not able to define any behavior of these mock objects. So as we are just implemented the same test cases as before, as in the animal service test without Mockito. So for the first two test cases not existing, you see it's three lines for each test, and for the third one, here are some additional ones for later examples. This is a two-liner, so it's not that much code, less code than before actually. So let's dive into the syntax of the Mockito tests here. What we actually see here on line 37 is the Mockito when call. It's something like stopping. We're saying that when the animal repository getAnimals method gets called, and the animal repository is a mock object, and if we call on that mock object the getAnimals method, then this call should actually return a list with two cats in it, a cat named Mike and a cat named Peter. That's what we define with this line here. So afterwards, we have just defined our stubbing. If we don't do anything of this, then default values are getting returned. For example, for objects, something like null. For ints, it might be 0. Methods that return an int and all these things. So there actually is something default mocking behavior going on. You don't have to define mocks for everything. There are some smart values just there, but not for this case here. We actually want the method to return something, the same as we did in the other example. Just the names are some different from the example before. So what we do next is on line 38, we call the method that we actually want to test. This is the animal service getAnimal by name method, which calls the animal repository getAnimals method to search for the animal named Mark. And we get a result from that. We get an optional of animal. And after that, we use the harm quest matchers, as in the other example, and check if the animal wasn't found, because in our case we want just to check if it wasn't found because it shouldn't be in the list. The same goes for the second example. It's all the same, but we have a different call argument here. That's the difference. So we have Mike here, so Mike is in the list, so it should return actually an optional that's not empty, and so the result should here somehow match against the true value. So as you now look back at the other example where we just wanted to somehow define a different return value for our method. As you can see here, and as you might have guessed already, is that easy. You can just define for every single stopping here, you can define another different return value. So just for the empty part where we want just to test if the what happens if the animal list in the repository is empty, then we just can say we can mock this method and say it returns an empty list, and then we can check our assumptions. That's as easy as it looks. It's as simple as that. There are more advanced features. We talk about the Mockito framework, but that's something I would like to show you in the next video. So for now, I would just like to finish with showing that the test case actually run. In order to do that, we just use the IntelliJ run feature here. So we run the animal test from our second example where we used Mockito, and see what happens here. Just wait and hope that everything passes. It actually should pass. So wait for it. And that's it. It passes. The same goes for the other test. I just forgot that in the first thing here. But it actually runs too, and it tests the same things as in the second example, except for the last two methods, which are additional here. But it's actually the same thing, but we had to write much more code than we did in this case, right? So there are different other mocking frameworks. I just showed you one of the most widely used ones. There are some others like JMock or JMockit or EasyMock. Power Mockito as an additional feature or additional mocking framework for using to mock static methods. So feel free to use anything you like. If you use Java, I would always say use Mockito because it's the best one out there. If you like to do some Groovy programming, I would say try to look a little bit into Spark. That's a really cool framework that I will show you in a video later. Because this is the most or the best natural language style testing framework out there from my point of view. So that's it for the first video, and I will show you some cool Mockito stuff in the next video. See you then. Bye bye.